Hello everyone. Let's solve another review question from the book Principles of Electromagnetics by Sadiku. And this question goes like this. So you have to match this side with the other side. Okay, first question says theta is equal to pi by 4. Just this much is given. That means our theta is fixed and we know this is from spherical coordinates. So it's rho theta phi where our theta is fixed. That means my r and my phi, they are varying. Okay. So suppose I draw this coordinate axis over here. This is z, this is y, this is x, okay, and my theta is fixed. What does that mean? That means the angle from z axis, that is theta, this is fixed at 45 degrees, okay. That means my r can vary from 0 to infinite and my phi can vary from 0 to 2 pi. That is, when it varies from 0 to 2 pi, that means like this or like this, depending on what my r is, like this. So you can very clearly see that I am getting a cone. Yeah, and yes, there is a cone in the option. That means when my theta is fixed and r and phi are variable, then the structure of a cone is being formed. Okay, clear? The next part is phi is equal to 2 pi by 3. Okay, 2 pi by 3. So in this, what will happen? Over here, my phi is fixed. Okay, that means my theta can vary, my r can vary. Okay, but my phi will remain fixed. Okay, so what, or if I use a cylindrical coordinate like rho, phi and z. Okay, suppose I use this and let me draw the coordinate axis. Okay, phi is fixed. That means my rho and my z will vary. Okay, that is rho will vary from 0 to infinite and my z will vary from minus infinite to infinite. Okay, so phi is basically the angle that one draws from this, from x-axis. This is 2 pi by 3. That means it is 120 degrees. Okay, 120 degrees. It will be somewhere here. Just the flat portion. Consider your floor otherwise. Okay. So basically this is the portion on the floor, and from here your phi, your rho can vary from 0 to infinite. How much ever you go, it can vary. Okay, and what else can vary? My z can vary from 0 to infinite. Okay, so basically if you take a close look over here, this is a surface that you're getting. Okay, if it's not clear, then let me draw another picture and where it will be pretty clear to you all. Okay, take it like this: z, y, this way x. Suppose let me use a fixed phi in this range itself so that you can understand. Okay, this phi is basically, how do you draw it? It's like you draw a part of a cylinder, right? You draw a cylinder like this, whose surface is like this. It goes like this, Hana, and then this is phi varying from 0 to full 2 pi. But suppose my phi is fixed over here, then I'll consider this this part, just this part, okay? It means this plane. I'll get this plane which can go up to infinite, and top down it can go anywhere. Okay, just this much. It means the plane here. This is z up to infinite. This is z up to minus infinite. And this row starting from 0 to infinite. And this is the whole plane. Okay, this is a whole plane. So if I have to match it from this side, then I can say which one I can say. I can tell it a semi-infinite plane. Why? Because my row varies from 0 to infinite. Okay, had it been varying from minus infinite to infinite, then I could have said it's totally a finite. I mean, totally an infinite plane. But this, I'll say it's a semi-infinite plane. Okay, the next is x is equal to minus 10. Well, that is pretty clear. I'm sure most of you must be knowing. X is equal to minus 10. Then you can draw a normal your two-dimensional plane also. Suppose you draw it. Okay. Anyways, okay. Suppose I draw something like this. Z, this is y, this is x, and if it's minus 10, that means this way, somewhere here. So basically this x is fixed, and you'll get a plane that is what, parallel to this, parallel to your I'll say parallel, not I'll say perpendicular to your x is equal to xy plane. Okay, x is equal to minus 10, so it will be somewhere like this, something like this. Okay, if you take it, if I draw like this, suppose y and this is x, just a 2D structure, and this over here is minus 10. In two-dimensional you get a line, and in when it becomes three-dimensional, that is upwards, suppose z is upwards, so this plane will also go upward. Yeah, so basically this is a surface that you're getting. Okay, this is pretty simple. This is nothing. Okay, so you can say it, you can tell it a infinite plane. You can tell it it's an infinite plane. Why infinite plane? Because your y can vary. Y can vary from anywhere, like 0 to infinite, minus infinite to infinite, anywhere it can go. And z also can vary from minus infinite to plus infinite. So it's totally infinite. Okay, infinite plane. Okay, over here, and you can see this is over here perpendicular to this x axis. Yeah. Okay, then next, our next question says r. Okay, r is equal to where did it go? Wait. Okay, you can see over here, r is equal to 1, theta is equal to pi by 3, phi is equal to pi by 2. So this is pretty clear that it's a point, because all the three coordinates are given. Okay, r is equal to 1, let me write it over here. R is equal to 1, theta is equal to pi by 3, and phi is equal to pi by 2. So this is a point, because all the three coordinates are given to you. So it will be over here, theta is given pi by 3, that is 60 degrees over here, and at about 90 degrees, and this r is 1, somewhere at 90 degrees. Okay, you'll draw it. So this point you can say is this. Okay, so it's clear over here. If all the three coordinates are given, then nothing to think about it, it's a point. The next is rho is equal to 5. Okay, rho is equal to 5. Then now let's see what will we get over here. Rho is equal to 5. Okay, when rho is 5, then what does that mean? That means rho is fixed, but phi and z can vary as much as it wants, okay? But you have to fix this rho. If rho is fixed, that is over here, this is 5, okay? This is your phi, it goes like this. This is rho, okay? So basically, suppose I'll vary phi from 0 to infinite. You'll draw it, but it'll be a what, circular thing, from with radius 5, and top and down you can go as much as you want, like a cylinder only, and z will vary from infinite to this over here minus infinite, like this sort of thing you'll get, okay? So basically, if I have to say what it is, I'll say it's a cylinder, okay? Yeah, it's a cylinder. Okay, then next what it's asking? Next is rho is equal to 3 and phi is equal to pi by 3. 5 pi by 3. Okay. So basically over here 2 coordinates are given. That is rho is equal to 3 and phi is equal to 5 pi by 3. Okay. So over here what is varying? That means z is varying. Okay. See, only one coordinate is varying. So and 2 coordinates are already given. You can think of such things like if you have 2 coordinates, then you'll get some line sort of thing, and if you have just one coordinate given, you'll get some sort of a surface, like a cylindrical surface or a plane or cone, whatever. Not cone. In cone though we had just one coordinate we were given. But when 2 coordinates are given, generally you'll get some line sort of thing, like this over here 3, this, and suppose this is 5 pi by 3. Okay, it'll be that side, but for convenience let me show over here. Okay, this is something like this. Okay, phi is also fixed. Okay, so if everything is fixed, then I'll get just this line, that's a big infinite line. I'm getting a straight line. Okay, I'm getting a straight line, and there you have it. This fifth one is a straight line. Okay, so generally, as you can see, when 2 coordinates are given, you'll get some linear sort of thing. Then next bit is rho is equal to 10 and z is equal to 1. Okay, rho is equal to 10 okay, I'm sorry, what's this? Rho is equal to 10 and z is equal to 1. Okay, so over here if I draw, what is it that I'm getting? My rho is fixed and my z is also fixed. Okay, what is varying? What is varying is phi. So phi I can vary it fully, completely from 0 to 2 pi. So basically, suppose z is 1 over here, and from here if I see like I draw a rho like this, it's 10, and from 10 I'll just go around it like this. So basically you're getting a circle sort of thing with radius 10, and the center is at z is equal to 1. Okay, so you're getting a circle. Let's see if it's on the other side of the options or not. Yeah, you have a circle. In the third bit you have a circle. Okay, then next what is it? R is equal to 4 and phi is equal to pi by 6. Again, you've got 2 coordinates. So let's see what is it that we are getting. R is equal to 4 and phi is equal to pi by 6. Okay, so basically two things are given. Yeah, phi is fixed. That means theta will vary from 0 to pi. Okay, okay. Then next, yeah, r is fixed. Okay, r is fixed over here, and phi is also fixed at 30 degrees. Theta will vary as much as you want. Okay, that means this is r. Okay, this is r, always fixed. Theta, this is theta, this will go on varying. Suppose this is just imagine it's somewhere 30 degrees ahead of it. Okay, then like this, r is fixed. So basically from here theta starts 0, and since your phi is fixed, you don't have to go anywhere round and round. This over here just till this much, because it varies from 0 to pi. So some semicircle sort of thing you got. So this is also like line, no, dl, you can go there. It's not a surface. So two coordinates are given, and generally you see it's all these sort of things only that you're getting. Okay, then r is equal to, next bit is r is equal to 5 and theta is equal to pi by 3. Okay, let's see. R is equal to 5 and theta is equal to pi by 3. Okay, so here what is it that you'll get? R is fixed, theta is fixed. Okay, then theta is fixed at pi by 3, 60 degrees, and this r is 5. So over here your phi can vary as much as you want, like this. It will vary. Oh, then though what is it you're getting? You're getting a circle. Okay, over here also you're getting a circle. Okay, fine. We're getting a circle. Actually, then the previous one, we got a semicircle, and here we are getting a circle. Okay, this is the circle that we got. Okay, I hope all these explanations are pretty clear to you. These are pretty simple questions, and these questions will clear out your basics. So these are very important if you are just starting to learn about these coordinate systems. So do check them out. Do try them out yourself. Thank you.